guys, another video. Again, working on something that my brother's bought. He's got a Hyundai little portable air conditioning unit. It was operating for about 2 weeks in the shop, and then the complaint was that it just went warm. So when I first looked at it, I could hear the compressor running, so I knew that it wasn't like a sensor was telling the compressor to stop working. So this is a very basic air conditioning system. There's not too many sensors like pressure sensors or anything like that. So my first initial guess was that it's lost pressure. When I opened it up, I did notice that there is a bit of damage. So obviously when the staff realized it stopped working because the full light was coming on, which means that this little container here is full of water, and sets off the little level sensor over there. It turns off the compressor. So they managed to drain that, and I assume in the draining process they possibly dropped it in this compressor, moved and hit there. So I assumed that there was a leak there. So what I did was this was normally just crimped off, this little tube here where they refill, and I just, when I cut that open, nothing came out, no gas came out, so I knew that all the gas was empty. And then what I did was I brazed on a little fitting. The fitting basically looks like one of these guys. Oh wait, that one's missing. Here's another one here. So I just put on one of these fittings, get it off eventually. You see it's got like a little valve in there. So I installed one of those and put my vacuum pump. This is the same setup I use when I work on cars, and when I initially did it, it wasn't holding any pressure. So then I had my little compressor that I just use on blowing up tires. It's just a little 12 volt one. I put 40 psi, and I found that the leak was coming from this tube here. You can see my really shitty brazing. It was the first time brazing. There's a big blob there that just kind of fell, but the hole was up the top there. It took a while to find it because it was like a pinhole, and that jet of air, I could feel the jet of air over here. So there's this jet of air that was coming, I could feel it here, so I thought it was like coming from down here, but anyway, it's coming from there. Fixed the hole, and then I pressure tested it. I need a 40 psi and held pressure. And now I've done a vacuum, I've applied vacuum pressure, and it's held like this for the last couple of days. Another little modification I did is from the back of this unit. So you have this lower tank, which from this, I think this is the condenser side, that's the evaporator. Obviously when it's vapor cycle's doing its thing, it condenses and then it builds up water, and so water builds up here, and then you got to drain it, right? Same with this, condensation builds up over here, and this little tray in there fills up with water, and then there's another place that you got to drain. So there's two parts that you have to drain, which can be a little bit confusing. So just to make it easier, what I did is just put this little bit of tubing up there and zip tied it down the side, so now when the water fills up here, it just drains directly into there. There's no real risk of the water getting in there because at least there's a fill sensor. So when that fill sensor goes off, it stops the whole process, it stops the compressor, and normally that stops the water buildup. So yeah, that's a little modification I did. Now the other thing I wanted to say was, so you need a Frigi license, right, to do this kind of stuff. But however, this lovely company, I think it's based in Melbourne, High Chill, they sell these cans. Now because of the size of the can, 400 grams, that means you don't need a license. It took me a while to find this, trying to hunt around for this can and this gas. I normally get the -30, which I use in the cars. As you can see here, it replaces the R134A and the 1234YF. So that's the one I normally use on the cars. And yeah, so now I don't exactly know, because normally on the compressor it will tell you what is how much refrigerant you need to put inside, and I can't see any sticker that tells me how much I'm supposed to put in there. So I'm kind of going to wing it with the pressure. So I'm kind of going to go off the Hydesure website what the pressures should be, and yeah, kind of go off that, and also just kind of feel it and see how the air conditioning unit is operating to see if I've got enough gas inside. So yeah, but first thing I'll do is I'll Google the compressor part number and see how much it should have, and then yeah, just kind of go off the pressures, what the pressures should read, and yeah, I'll get back to you. So I've regassed it. It did take me a while to figure out. Initially what I did is I added gas. I was looking at the pressures, and from my previous experience working on air conditioning units, you always add the gas to the low side. So obviously if it's adding to the low side, that's the compressor inlet side. So it's actually sucking the gas in, which makes sense. You also don't need to have high pressure source to pump it in. Now, this unit was never designed to be refilled. It's you top it up, it leaks, you throw it away. I didn't really like that idea, so I've installed this fill port. And initially, when I connected it, I didn't actually think about where it was that I was connecting it. I just assumed that you'd always have a fill port, because this is where it was capped off before, that this fill port would always be to the low side. And the pressures I was trying to get for R32 on the low side was around about that 70 psi, and when I got it up to the 70 psi, it just didn't work. The compressor was super hot because it was always running, it just never was cycling. So then I thought I'd maybe overpressured it, so I had to drain some gas, and then I kind of just sat and thought about it for a while, and then I looked, and as you can see, this is the outlet from the compressor going into the condenser. It runs through these tubes and then comes out here, high pressure, and then it goes around this little capillary tube into I think that's like the TX valve, so the expansion valve, and then into the evaporator. I think I've got that the right way. I'm pretty sure that's the condenser and that's the evaporator. And what I found was this would ice up within the first couple of seconds, and it'll just ice up around here, and there's that fluffy ice. And I'm no Friggy, but from what I read and my understanding of the theory, that is an indication of, it could be an indication of overpressure, but that was an indication of under pressure, undercharge. And so it just really wasn't working. So what I found was I increased the charge. I got it up to, now obviously you can't add gas with the compressor running because it's only going to increase the pressure. And these little cans, they only hold around about, I think, 160 psi. So I got it up to around about 150. Compressor would run, the pressure would increase up to around about that 200, 210. The air was cold, but the evaporator side, on the evaporator side here, I'd only see a build-up of condensation to around about halfway. And so it was a bit of a trial and error to find out exactly how much gas, because on the compressor, normally on the compressor it tells you how much weight of gas you should add, but there was no sticker anywhere. I've obviously added the sticker, but there was no sticker about how much weight should be on here. And that's obviously because it's not, I guess, not supposed to be serviced. So it was a bit of a trial and error. And what I found is when the pressure gets to around about the 280 psi, the evaporator is, the full evaporator is efficiently cooling. So the condensation you'd see would build up to around about this mark. And the air outlet was significantly cooler. I wouldn't say it was the best, but unfortunately I can't get any more pressure or any more gas into this because these cans are, set at a certain pressure. So the max amount I've got in here is that amount, and it operates, I think ideally this one would operate just above the 300 psi pressure, and I think it would work quite well at that point. So I'm going to turn it on now. Obviously you're not going to see anything because I haven't got it connected. I've capped it all up, did a little leak check, little leak detector, and yeah, there's no leaks there, which is good. So yeah, I'm quite happy. It's all working, and it's significantly cool. It's quite noisy. That down low. Don't know what that's going to do, but it's on there initially. So that's nice and cold, but you can see it's not icing up. Before it was icing up straight away as soon as you turn it on. So that was telling me that the system wasn't balanced, it wasn't efficient. And now it's just cold everywhere through the whole system. Which, like I said, I'm no fridgie, but I think that's a better operation than it freezing. And yeah, the air is cool. So 16 degrees, that's max cool. I wouldn't say it's 16 degrees right now. Well, yeah, getting there. Starting to heat up now. This is getting quite warm. So I'll let it run for about maybe 10-15 minutes. Oh yeah, now it's really starting to get cool. 10-15 minutes, put it all back together and then return it back to my brother's shop. See the water condensation starting to build up. That's cool there. Yeah, so I am quite happy with that. So yeah, as you can see, the water condensation builds up. You can see it building up quite rapidly on this. And then it comes down its normal drain, and normally they would have to remove this bung and periodically remember to drain this. Now I've just done this little modification where I've inserted this tube, so it'll just fill up as and when it does, and it'll drain down this hose into the tank, and at such a time when the level starts to fill up and it triggers that fill sensor, it'll then shut the compressor off. So I think that, oh yeah, no, it's cool. Yeah, that's nice and cool. So I think that is a job well done. Oh yeah. I suppose just on another side note about this company, High Chill. Obviously, as you can see, I'm quite a big fan. So the High Chill -30, this is the replacement for the R134 Alpha and the R1234YF. The 1234YF, that's in my Audi, and the 134 Alpha is in my other car, the older one. The HC32 replaces the R32. The -60 is used for, yeah, they call it a hydrocarbon blend refrigerant grade. This, I believe, replaces again the R32. I'm not 100% sure why they make this one, if this one does both, but this also does the 410. So my air conditioning unit has 410 in there. So I plan, no, I've never touched my air conditioning unit for over 10 years, and it's been working quite well. I mean, the last 2 years it seems to be a little bit less efficient. It takes a long time to get cold, so it might need a little bit of gas. So I might just, that's why I bought this one, just add a little bit of that. But yes, High Chill, they make these little cans, little top-up cans, and like they say, it replaces these gases. It's their own battery blend, which has a much lower global warming effect, which allows you to buy these cans as they are with this amount without the need for a license, which is awesome. So you don't need a special HVAC license to get these cans. So yeah, great company. I've used them for 2 years now. Cars, commercial air conditioning units, and that's just the shit that was in there. So yeah. The other great thing is on their website for the car, they have a manual there, and it will give you a range of vehicles, because it replaces, like it says, it replaces this, these gases. It is not a 1-for-1 weight ratio, which means that you wouldn't add the same amount weight for 134 to what High Chill's brand. So just off the top of my head, like on the Commodore, it needs whatever it is, 0.9 or something. You only need 0.4 of a kilo of the High Chill stuff, which is great because this basically comes in 4.25, and you buy 2 of them and you're good. So yeah, great little product. They also come with their, if you buy them, you need to have the little adapter, can adapter. This was the original one that I bought. To be honest, it's pretty shit. This little cap would break, as you see it corrodes. And I've recently just bought their other one, which is this one here, the Can Valve Pro. Look at that. So yeah, I haven't used it yet, but I imagine it looks a little bit better than this one. So I imagine it probably works better as well. So there you go. How's this? Oh yeah, that's nice and cool.